Hello, everyone. What we are going to talk about today is real-time message handling and notifications with API platform and Symfony. So first, let me introduce myself. I'm Allison Guilhem. I work at Les-Tilleuls.coop as lead developer. I contribute to Symfony and API platform. And you can find me on GitHub, Twitter, LinkedIn. I will be very happy to have a chat with you, so come and say hi. What I propose is to divide this talk into two main parts. First, real-time notifications, techniques and protocols, and then real-time notifications with Mercure via use case scenario. So, when you're on a page and bam, the content updates right in front of you without you even touching anything, like, say you're working on a document with someone, collaborating in real time, and suddenly, you see a change pop up from your colleague. So, real-time communication is all about pushing updates to users, broadcasting information as soon as it's relevant. Or, even, notifying a user that, when a big asynchronous task finishes, like some heavy processing or calculation, and you want to know the moment it's done, especially, if it's something important. So it's all about keeping everyone in the loop right when it matters. So, one big question is, how does it work? Well, let's take a quick step back and revisit one of the core building blocks of our application, the HTTP protocol. So, don't worry, I'm not here to give you a history lesson on HTTP's evolution. You can find all that online. But let's hit a few key points. HTTP was originally designed to transfer hypertext documents between a client and a server. And while it's evolved from HTTP 1 to 3, the core idea remains the same, a request-response model. So HTTP 1.0, the first, standardized version, introduced features we still use today, like HTTP headers, status codes, methods like post and head, but it wasn't perfect. Each request needed a new TCP connection, and it was so slow, when you have to handle multiple requests. So HTTP 1.1 fixed a lot of these issues by allowing persistent connections. So, multiple requests and responses could happen over a single connection. And it also added things like chunk transfer encoding and better caching, making it more efficient. But, let's be real. When we are coding, performance is key. It's like having all the freedom to do what you want, but you need it to be fast. And how quickly information is served and minimizing delays is so crucial, So we needed HTTP 2. And it brought major changes like, moving from a text-based protocol to a binary one, which made things faster, And, it introduced multiplexing, allowing multiple streams over a single TCP connection, header compression as well, and server push. So, server could send resources to clients before they even ask for it, like, JavaScript files, CSS files. So, boosting performance even more. And the latest evolution is HTTP 3, which tackles, the limitations of TCP, especially the head-of-line blocking issue in HTTP 2. It's based on the QUIC protocol and uses UDP instead of TCP, which means, faster connections and better performance. Sorry, music to my ears. Especially, in high latency or loosey environments. And it's got security built right in, making connections, more secure by default. So now, can we really do everything we want right now and handle real-time notifications flawlessly just with the HTTP protocol? No, not exactly. Even with the latest versions of HTTP, like 2 and 3, we're still not quite there when it comes to real-time notification. They do improve it for sure, but there are better tools out there for the job. So let's have a look at the techniques and protocols. HTTP polling. So this is, the most basic approach where the client repeatedly asks the server for updates at regular intervals. So, it's super straightforward. It just uses standard HTTP requests and responses. So you don't need any special setup, It doesn't require keeping connection open, which can simplify things, on the server side. And the time it takes to get updates depends on how often you poll. So poll too often and you will stress the server. Poll too rarely and you will have outdated data. So, a very complicated balance. And it can also mean, wasted bandwidth and server resources, and it's completely inefficient for real time because it's based on periodic checks. So you will always have some delays, or, you might be extremely lucky, but let me know. Long polling keeps, the connection open until there is new data. So updates are sent as soon as they are available. So, cutting down on delay. But, so, it's good because it's going to reduce, unnecessary network traffic compared to regular polling. But keeping connections open can put a lot of strain on the server, especially with many clients. So it's more complex than basic polling, for sure. And you can have some scalability issues as well. So server-sent events. This is a bit more advanced, SSE use a single long-lived HTTP connection that the server keeps open to send events to the client, which, makes it a breeze for pushing updates like new feeds or stock prices. So it's part of HTML5 plugin, and on the client side, usually you set up a JavaScript event listener to handle these updates. You have automatic reconnection. So, the connection drops, SSE clients automatically try to reconnect, which is really great for resilience. It's text-based protocol, so very easy to debug. But it's unidirectional communication. So SSE only sends data from the server to the client. If the client needs to send data back, you will need additional infrastructure. So, yeah. And you can have some scalability issues as well, because SSE uses one connection per client, which can become, a burden on the server when dealing with lots of users. WebSockets. So this is a lower level protocol than HTTP. It starts with the HTTP handshake, but then, it upgrades the connection to a WebSocket connection. So, you're going to have a full duplex bidirectional communication channel where both, the server and the client can send messages to each other freely. So they provide a lot of control, but, they come with some, drawbacks. Like, for example, they don't handle things like authorization or reconnections or, state reconciliation out of the box. You need to implement those separately. And, they don't fit as neatly with HTTP 2 and 3. So okay, they support binary and text data, but they are way more complicated to implement, especially, if you're not really familiar with the protocol. Managing a large number of persistent connections, can be resource intensive, so requiring careful planning, around load balancing and failovers. And because they operate outside the usual, HTTP protocol, they can introduce security risks. So you will need to secure them properly. So be careful. And when I chat with colleagues or look at their implementations, I often see real-time features being built with WebSockets. They're a great fit for it, for sure. But, implementing WebSockets in PHP isn't exactly a walk in the park. It doesn't really work well for long-lived connections, so not really great. Also, I just want to mention quickly 3 others protocol. WebSub. So it lets servers subscribe to updates via webhooks. However, it's limited to server-to-server communication. Also, I don't know if you heard about that, but BREAD and PrEP, so per resource events protocol, but it's just some proposals. It's not fully implemented yet. And one common problem is they need a persistent connection between a client and a server for each resource. So this isn't always supported by technologies like PHP or serverless setups, and browsers also limit these connections, even if it's better since HTTP 2, but it's not really good. So to tackle these issues, Mercure protocol was created by Kevin Dunglass. It's designed to make real-time updates easier and works well with modern web tech. So Mercure is built on top of HTTP and uses service and events, a persistent connection mechanism that has been, supported by all browsers and proxies without, needing extra libraries. I mean, maybe for Internet Explorer, very old version, you're going to need a polyfill, but all right. So here's some cool stuff about Mercure. No extra setup needed, compatible with any server, automatic reconnects and syncs, so no sweat, secure with Dot, high performance, GraphQL and hypermedia friendly, built-in encryption, and backward compatibility and other stuff. So, perfect candidate, right? I mean, Mercure isn't just about doing real-time well. I mean, this is good, of course, but it's about making it easy, secure, and efficient across a bunch of different platforms and environments. And, without all the usual headaches. So this is, the main mechanism. And what is important to notice is that your application is not strictly required to use a dedicated Mercure Hub server to handle real-time updates. Because your application, can implement the Mercure protocol directly. For example, if the programming language being used support long connection, but it's still a good idea to keep everything separated. So up to you, but here we're going to use, a dedicated Mercure Hub. So let's dive into how we can use the Mercure protocol with a practical example, an online casino platform. So we have a platform where users play, online games. And these games come from different providers, each, with their own APIs that you can query for game details or other information. Just like, in a real casino, there could be actions that are not allowed. So we have a system that monitors player activities on the gaming platform. So when a player, performs a suspicious action, such as, an attempted fraud or an unusually high bet or a connection from a restricted country, the administrator must be immediately alerted via the admin dashboard to take corrective actions instantly. So let's set aside, the actual gaming part, but don't worry, it's going to be fun, and focus on the admin dashboard, which is built, built with Symfony and uses API platform for their API. So using Mercure, we can handle these real-time updates efficiently. So, everything stays synchronized and up to date without any delays. So let's go. First off, setting up Mercure is pretty straightforward. So here we are using Symfony with Docker. So you need to install, Mercure, so Composer. Symfony Flex can handle the Mercure Hub installation for you. And you just need to run, Docker Compose app to start it. So, it's a very smooth process to get everything integrated and working. The Mercure Rocks Hub is available as a custom build of the Caddy web server. So, of course, you're going to have some variables, for your hub, for example, but you're going to need to update the values, of course, be careful about that. So you're going to have the Mercure _publisher _JWT _key, etc. And in your .m file as well, for your application, you're going to have some variables like the Mercure URL, public URL, etc. So you need to update the values, of course. Just a point. If you're using Franken PHP, it comes with a built-in Mercury hub. So a good reason to use Franken PHP. Another important point is the mercury.yaml configuration file created when you install Mercury bundle. In this file, you can define multiple hubs and specify a default hub, and each with, its own URL. So the Jot configuration is particularly important. It's crucial for both, publishing and subscribing, and we will see it in our case. So, you have a few options for setting, the JSON Web Token. So you can directly specify, a direct value. If you do this, other fields will be ignored. Or you can provide a service provider that will return your Jot. Or you can use a factory to create tokens that allow publishing and subscribing. So by default, if you don't specify a direct value, you don't specify a provider, you don't specify a factory, it will use L-Kobuchi factory, which will handle token creation based on the provided passphrase, secret, and algorithm. What is important to know is internally, a factory token provider would then be created to manage the token generation for publishing and subscribing. And passed to your provider, the subscribe and publish claims that you can see here are very important because, they define what actions are authorized when using the Jot. So additionally, you can set a default cookie lifetime, which, determines how long the JSON Web Token, or Jot cookie remains valid. If you're in development mode, there is a very handy debugging tool. But I have to be honest with you, and sorry, Kevin, about that. At first, I hated it. I thought it was really complicated and I couldn't understand a thing. But now I think it's really useful, so don't hesitate to have a look at it. Now that we've got, everything set up, let's talk about how to subscribe to updates and publish, these updates using Mercury. So API platform is able to detect changes made to our Doctrine entities and sends, the updated resources to the Mercury hub. The Mercury hub then dispatches these updates to all connected clients using servers and events. So, that's the mechanism we'll be leveraging. So, in our case, when a suspicious activity occurs, the gaming service will call an API endpoint related to the suspicious activity resource. So this suspicious activity resource will include information like the date, alert label, game ID, user ID, and other information. So for this resource, we will add the API resource attribute, and we will include the Mercury true option. The Mercury option, and we set it to true. And what's really cool? It's that by simply setting Mercury true, it automatically enables publishing updates to our Mercury hub. That's it. But, it's going to be, you can use it like this, but sometimes we need to configure things a little bit. So here's a bit more on what we can configure. Topics, so one or an array of topics. If not provided, the resources internationalized resource identifier is used at the default topic. So on the publisher side, think of topics like, labels or categories, that define what the update is about. And on the subscriber side, subscribers, they're going to use these topics to filter what they want to receive. So topics help connect, the right updates to the right people. Data, this is the content of the update. If you don't set it, the update will default to the serialized form of the resource. SSE ID for this event, if not set, the Mercury hub will generate an ID for you. The type of SSE event, the retry policy for SSE events, normalization context. This specifies, the context to use for normalizing the update. But now, let's talk a bit more about how we define topics. So you're gonna have two main categories: static topic and dynamic topic. So static topic, these are topics, with fixed, predefined identifiers. So they don't change based on resources or one of the resources relation, They're used to broadcast information to a wide group of subscribers. Dynamic topic are created on the fly. So, usually they are based on variables like, the resource ID. For example, in Symfony, you can use Symfony expression language to generate dynamically the resources internationalized resource identifier. Also, it's possible to generate, the topic URL using the object's absolute path. So they're really ideal for, targeting a specific subscriber or group of subscribers. As a dynamic topic, you have a relation-based topic. Usually you're going to know it as a restrictive update. That includes both, the object's relations internationalized resource identifier and the object's internationalized resource identifier as a query parameter. So the whole point here is to make an update that is tied to an object, but also to its relation. So it's super handy for things like permissions or targeted notifications. This restrictive update is really interesting for our case. So, for example, in our case, there is a scenario where a subscriber wants to receive updates about all suspicious activities they have access to. So if we set up a general topic, some subscribers might get updates about every suspicious activity, which isn't ideal, because instead we want to ensure that the subscriber only receive updates about activities relevant to them. So like those related to their own group or, to their role as a coordinator. So, But what's really cool is that for this resource, we can also set a canonical topic, so a general one, for all the subscribers who don't have this restrictive update in their Mercure subscribe claim. So, they will receive updates for all activities, while, the ones with the restrictive update will only receive the update about all suspicious activities they have access to. That's the difference. So this setup is really, powerful because it allows us to manage permissions and control exactly who gets which updates, making our system, modular and secure. So it's pretty good. The publishing mechanism is pretty cool. As you can see on the slide, there is a listener that hooks into the flush and post-flush events. Basically, it checks that the options passed are correct, and then builds an update that looks like the one you see here. So another interesting thing is that by default, if enable async update option is not specified, it will set it to true. This means that instead of publishing directly to the hub, the update is handled by Symfony's messenger component, and allowing it to be processed asynchronously depending on your configuration. So you just need to ensure that the update, which is essentially the message, is routed to your transport. Otherwise, it will be managed synchronously. So in order to publish to the hub, it grabs the JWT, the JOT, and sends the post request to the hub. So as a reminder, if you remember what we covered, a few slides back about the JOT, how it can be obtained, it's important to note that when publishing, a token is sent. And one of the topics must match the published claims in the token. Otherwise, it won't work. So enable async update option is very important when you have a lot of updates in a very short period of time, because otherwise, the hub is asynchronous, so you don't really need it. This approach boosts performance and keeps the main processes of the application running smoothly, which is very super, important in a high traffic environment like, an online casino. So the system can better manage traffic spikes like during peak gaming events or multiple fraud attempts. So it keeps, the notifications flowing smoothly without slowing down the overall system. So basically, there are two big points. For an update to happen, the topics between the subscriber and the topic publisher need to overlap and match, at least in part. And the token, when you publish, must overlap with those mentioned in the topic. Otherwise, it just won't work, and otherwise, you will have the 4.1 error. So, are we happy with that? Should we stop here? I mean, it works well. It's really great. But sometimes it's not enough. For example, activities detection, especially fraud detection, often involve complex calculations or interactions with external systems. So doing these operations in real time can be, really resource intensive and could slow down the whole system. So instead of just using Mercury directly for real-time updates, a more sophisticated approach, will be to leverage the Messenger component directly instead of the Mercury one. So, when a suspicious activity is detected, instead of immediately publishing an update, we push a message into a queue using Messenger. Just like, the Mercury option, there is also a Messenger option. So, as you can see on the slide, you can set it to true, and whenever a resource is created, updated, or deleted, it will be dispatched via Messenger. Once the message is picked up from the transport and routed to the handler, it's up to us to perform any calculation or whatever you need, like making calls to an external API or multiple APIs, and then you create the update yourself that will be published, to the hub. And to create that update, it's super straightforward. You're going to use the update class. So, what if I told you we could actually take this process to the next level? I mean, at the moment, it's just a proposal since, the PR is currently open on Symfony. But here's, the cool part. What if we could handle messages concurrently instead of sequentially? Because that kind of approach will help us avoid bottlenecks when some messages, take longer than others. So let's see how it would work. It's not working at the moment. So instead of setting the messenger to true directly on the resource, we are going to specify a processor. As you can see on the slide, we will have our processor that, for instance, persists the data and also dispatches it into the bus. And as you can see, there is a stamp attached. So this stamp is key because it specifies that the bus dispatching the message should pass through the parallel bus. That's a new bus. And it's, this bus that will allow the message to be processed concurrently. So when configuring, you can define, how many processes should be batched and run concurrently when you launch, the worker command. And so, and what is planned, in these sub-processes is to have a cache container. And for better performance, you have to use, the parallel extension, which depends on ZTS. But, the cool part is with FrankenPHP, ZTS is already enabled, and Parallel has recently become compatible with FrankenPHP. So another good reason to use FrankenPHP. So, for example, by doing some benchmarking, you could significantly improve the processing time of messages since, they are handled concurrently. Depending, on the scenario, it can boost performance by up to 5 times. So it's not nothing. So at this point, we need to make sure that only the subscriber side, on the subscriber side, the subscribers can actually receive the update and that they receive the right update. So I don't know about you, but I reckon the topics and claims are going to be crucial here. And indeed, first of all, it's super important to be able to easily identify the hub's URL. And for that, you should know there is a discovery mechanism. When you add the API resource attribute with Mercury, you get to know that API platform automatically adds a link HTTP header onto all the responses for that resource class. So, it's really easy to just do a fetch, or if you're already on a page linked to that, the link should be here. Otherwise, if you are using Symfony, you can actually create those link headers with the Discovery Helper class. So, yeah, pretty good. So basically, we will need to open a persistent connection to the hub, which will push the events that have been published to it. And we are going to be using the event source interface, which is basically the browser's way of handling server-side events. So the idea is to form the correct URL and then pass it to the event source interface to open the connection. To receive an update, the topic presented by the subscriber must match one of the topics of the update. Otherwise, logically, nothing will be received. If we use subscribing with Symfony, Twig provides a very handy Twig function called Mercure. This function is super useful because, when setting up subscriptions, you can specify the topics you want to listen to, either, as a string or an array, and you can also include other options. And this function generates a URL that you can pass directly to the JavaScript new event source. So with this setup, all subscribers will receive all updates that match their subscribed topics, the first one on top. But in practice, like in our use case, we often need to add a private dimension to it. So in our scenario, we are restricting subscription access to authenticated clients, meaning they must present a valid JWT, a JSON Web Token. So this is going to add a layer of security. And as a second argument, for instance, if you're using the Mercure Twig function, you will need to at least specify the subscribe claim that you are targeting. So, for the event source in JavaScript, make sure, when you want a private update, a private, subscription, make sure you set, with credentials to true. This is very important because cookies are automatically sent by the browser when opening an open source connection if the with credentials property is set to true. So when you do this, what happens is that, as you can see on this slide, a Mercure authorization cookie is created, which holds the JWT, And if we take a closer look at what this JWT, contains, we will see the Mercure subscribe claim, which allows, the hub to determine if the client is authorized to receive the update. So a crucial detail here is that you need to have a token factory defined, at least, a default token factory. Otherwise, you will encounter an error. So, or you can just use another way and don't use the Mercure Twig function. So the JWT should be short-lived. For example, you can set an expiration time in the additional claims, for the cookie. So Mercure helps keep everything in sync, even, when connections drop. If a connection is lost, it automatically tries to reconnect by sending this special header, the last event ID, to catch up on any updates that were missed, while it was offline. And actually, you can define this, in the Mercure options within the API resource using the ID. I don't know if you remember. If you don't set it, the hub is really smart enough to handle it automatically, so no worries about that. And this is really crucial for us because if it loses the connection, it will reconnect and use that last event ID header to retrieve any missed updates. And it's automatically so. Generally, there are 3 ways to authorize. Using an authorization HTTP header, this is, the go-to method if the subscriber is not a web browser. So the header must contain, the string bearer, followed by space, and then, your JWT. Also using a cookie. So it's preferred to name the cookie Mercure authorization. And in fact, Symfony's Twig extension does this for you. But don't do it, actually. An authorization URI query parameter, but again, don't do it because it's not secure at all. It's really, if it's last resort, option when nothing else works, but even in that case, try to do something else. Or, if you have to do it, you have to set a cache control header with the no store option, and if the server responds successfully, include cache control header with the private option. And of course, it's always best to use encryption to secure everything. Sometimes, it's more convenient to set the authorization cookie directly in your code instead of using, for example, the tweak function. So Mercure bundle provides a service called Authorization, so you can use that. But be careful to not set the cookie twice. So one of the issues you can run into on the client side is that you might end up opening multiple connections or even forget to properly manage opening and closing, the event source. There is a super handy, library with the Mercure function, not the tweak function. So it's going to fetch the hub URL and topics, stores the topic in memory, then closes any old event source on that hub, and reopens it with the new topics, including the latest one. So it basically prevents you from having scattered subscriptions and multiple connections all over your code. So it handles, all the topics on a single connection and manages, the opening and closing of the event source for you. So really neat solution. One last thing I want to talk about is Mercury's Active Subscriptions API. So this was really useful, for my online casino case, especially, when it comes to tracking who is active, particularly, for spotting, suspicious activity like certain changes in betting patterns. So thanks to the API, we can keep track of which subscriptions are active or terminated. So this is really crucial for real-time systems like online casinos where monitoring, active sessions is so important. So, you can list all subscriptions, show subscription for a specific topic, or provide details for, a specific subscription. So also, the Mercury claim or the JOT can also contain user-defined values under the payload key. So you have the subscriber, publish, and payload. So it's a convenient way, to share data related to one subscriber to other subscribers. So that's it, I guess. So, Mercury provides a very robust solution for real-time communication. I mean, it's very easy to handle, scalable updates and deliver, instant notifications. So it's very ideal for dynamic application. It's a key protocol for meeting, modern real-time communication demands. And a little message for, to the Laravel community. I don't know if there is someone here, but don't be jealous of such a great integration with Symfony. I mean, there are some exciting developments on the way for server and client integration with Laravel Broadcast and Echo, if I'm not wrong. So don't be jealous. So thank you very much. If you have any questions, I'm here. I mean, maybe later.